Hey physics fans, today we're talking about conservation of energy. Remember, conservation of energy means that energy cannot be created or destroyed, it is just transferred or converted. Before I get into how we got to this equation, I want to talk about a couple of things from the previous chapters. Remember, in chapter 7, it talked about work from A to B is equal to the change in kinetic energy from A to B. In chapter 8, it talked about that the change in potential energy from A to B is equal to the negative work done by conservative forces from A to B. Now, if I combine these two equations, I get that the net work is equal to the work due to non-conservative forces from A to B minus the change in potential energy from A to B, and that is equal to the change in kinetic energy from A to B. If you're confused, think about section 8.2 where it talked about conservative and non-conservative forces, and we have to consider them both. Now, if I take this quantity, I move it to the right-hand side of the equation, I get the work due to non-conservative forces is equal to the change in mechanical energy. You might still be asking, what does this mean? This means that the mechanical energy of a system is constant until a non-conservative force does work on the system. Now, to help it make more sense, I'm going to direct your attention to my system and my graphs. The graphs have energy, total energy, potential energy, and kinetic energy at points A, B, and C, corresponding with points A here, B here, and C here. Now let's say I take the mass at point C, which is a reference point here, and the potential energy at this reference point that I designated is equal to 0. I move the mass from point C to point A. I have displaced it a height of y. Now the potential energy is equal to mgy. When I release the mass, it is going to go from point A to point B. It's approximately half the distance to point A, meaning I have about half the potential energy, and the other half of that potential energy was transferred to kinetic energy. When that mass goes from point B to point C, all the energy that was potential energy from point A is now transferred to kinetic energy at C. Remember, at my reference point, the potential energy at C was equal to 0, and that is still the case. This system will continue going from A to B to C to here and back because I am out of the system. I was a non-conservative force. Therefore, the mechanical energy of this system will remain constant. To the window, to the wall. All these problems solved. All these problems.